Good evening. Hello. Thank you. Thank you, David. My name is Caroline Jean Fernald. I am Executive Director of Harvard Museums of Science and Culture, a partnership of 4 public-serving museums where our mission is to foster curiosity and a spirit of discovery in visitors of all ages, enhancing public understanding of and appreciation for the natural world, science, and human cultures. With this mission in mind, I am delighted to welcome you to tonight's program, co-sponsored by the Harvard Museum of Natural History, the Harvard Museums of Science and Culture, and Harvard's Brain Science Initiative. We are grateful to Parazad Bilamoria and Adam Zajac from the Harvard Brain Science Initiative for inviting us to collaborate with them to present this program. We have partnered with HBSI to deliver many events, and it is always a pleasure to do so. This event is held in celebration of Brain Awareness Week, a global campaign to foster public enthusiasm and support for brain science. We are honored to have Jorge Cham and Dwayne Godwin with us tonight, who will speak about their new book, this one right here, Out of Your Mind, The Biggest Mysteries of the Human Brain, which was published this past January by Pantheon. After the lecture, we invite you to join us in the galleries of the Harvard Museum of Natural History, where you will be able to buy a copy of the book and have it signed, meet and chat with brain scientists working on various research projects here at Harvard, and if you wish, stop by the cash bar to grab a drink. Our staff and volunteers will guide you. We all wear these little pretty red badges. They're easy to spot. HMSC's partnership of museums crosses many disciplines, and we host a wide array of events throughout the year at our 4 museums. To learn more about additional upcoming museum events, I invite you to visit our website, hmsc.harvard.edu, where you can sign up for our newsletter, or you can also follow us on social media. We are grateful to all our members and supporters for making these programs possible. It is now my pleasure to introduce the authors of Out of Your Mind, who will discuss the making of the book and share insights about its content. Jorge Cham is a Daytime Emmy-nominated and bestselling cartoonist/creator of the popular online comic strip Piled Higher and Deeper, also known as PhD Comics. He is the co-creator, executive producer, and creative director of Elinor Wonders Why, one of the highest-rated animated shows on PBS Kids, and the co-author of 2 popular science books, the best-selling and award-winning We Have No Idea, A Guide to the Unknown Universe, and frequently asked questions about the universe, as well as the children's book, Oliver's Great Big Universe. Jorge is also the co-host and co-creator of Daniel and Jorge Explain the Universe, a popular podcast and radio show. He obtained his PhD in robotics from Stanford University and was an instructor and research associate at the California Institute of Technology from 2003 to 2005. He's originally from Panama. Dwayne Godwin is a neuroscientist, educator, and academic leader who is a professor in the Department of Translational Neuroscience, and served as graduate dean at the Wake Forest University School of Medicine in Winston-Salem, North Carolina. His research centers on the cellular basis of abnormal brain rhythms, including active projects on calcium channel function, epilepsy, and traumatic brain injury. His goal is to use emerging insights from the brain to develop treatments and potential cures for neurological diseases. His science outreach includes Mind in Pictures, co-created with Jorge Cham for Scientific American Mind, as well as blogs for the Society of Neuroscience and the Museum of the Moving Image. Please join me in welcoming Jorge to the stage to begin the program.
Hey, how's it going?
Good.
Oh, you don't sound very excited. We'll try it again. How's it going?
Great.
All right. Not much better, but I'll take it. Well, my name is Jorge Cham, and I'm here with my co-author, Professor Dwayne Godwin, and we're just going to talk about our new book, which is Out of Your Mind. Now, I'm going to talk for a few minutes, and then I'm going to hand it off to Dwayne, and I'm going to be drawing in the background while he talks. And you should know, we've never done this before. So we have no idea how this is.
It's an experiment.
It's an experiment, yes. We're doing live science right here. But yeah, so my name is Jorge Cham, and I'm a cartoonist. As was just mentioned, I'm the main creator of a television show called Elinor Wonders Why, a book series for kids called Oliver's Great Big Universe. And actually, I'm now the host and producer of a new podcast with iHeart called Science Stuff. Just premiered yesterday, actually. Yeah, so please, thank you. Oh, great, thanks. Thank you. Hope you check it out. But I'm also a roboticist. I have a PhD in robotics from Stanford. Now you might be wondering, what does having a PhD in robotics have to do with creating television shows and drawing comics? Well, I can tell you that my parents are also very confused about that. But I do have a PhD from Stanford. And in fact, my thesis focused on making these small robots that could run like cockroaches. I'm not sure why you're laughing at my thesis. But here's a quick movie of what these robots look like.
There's a reason you became a cartoonist.
Yeah.
I mean, it's having a seizure.
Yeah, basically that's the main reason I'm showing you this video. First of all, I feel like this video really kind of captures what getting a PhD feels like. Some of you may know the feeling. You feel like you're running frantically the whole time, but you're not getting anywhere. Meanwhile, there's a more intelligent being stamping you down. But no, I also like to show this movie because it's really the only way that anyone will look at my research anymore. Gotcha. Because apparently much more popular than the research I spent years working on, more popular has been what I was doing when I should have been doing research, which was to make these comic strips called Piled Higher and Deeper, or PhD comics. These are comics that I started while I was a graduate student. I posted them online. They sort of went viral, and I became really popular in the university campuses everywhere. So I went on this huge speaking tour for many, many years. I visited over 400 universities, gave over 400 talks out there in the world. And in one of them, I just so happened to meet a professor of neuroscience and psychology who also loved comics. And that is Professor Dwayne Godwin. And so I'm going to hand it off to him now to talk about how we started working together. Yeah.
Thank you. So first, I want to thank all of you for being here. This is a little different kind of talk than I usually give. I'm usually lecturing to medical students or graduate students and giving scientific talks at meetings. So, an audience like this is a real challenge to me. So I went back in time to the kinds of advice that I would give my students when they're giving talks. And the first thing was that I always told them is pick somebody in the room and give your talk to that person. So you young lady, you're lucky tonight. I'm going to give this talk to you. The other thing is to picture everyone in their underwear. And by the way, you all look great. Have you been working out? Because you look wonderful. So all of that aside, the main thing that I landed on was just simply expressing what I feel, which is real gratitude about the reception of this book, which was really very much an experiment for us, but also gratitude for you for hosting us and for the Harvard Museum of Natural History for providing the venue and the family of Harvard Museums for supporting this event. So yes, we wrote a book, and I need a clicker. And this book is about you, essentially your brain. But it didn't just come to be out of nothing. Like every good comic book story, there's an origin. You got to have issue number one where you set the stage. And so Our origin story starts 15 years ago. So Jorge and I go way back. It's really kind of scary, honestly, when you think about it, how long we've known each other. And he doesn't age. I don't know what it is, but he stays the same. And meanwhile, I'm falling apart. So something weird's going on. But Jorge at the time, 15 years ago, was giving this talk called The Power of Procrastination. The Power of Procrastination. And what it was a wellness talk encapsulated inside or wrapped up inside humor. And it was a really important thing for our students at the time. I don't know how many of you are in graduate school or in med school or as students of some kind, but you know how stressful things are right now for you. And so I have a lot of compassion and empathy for what you're going through right now, but it's the same story. 15 years ago, we still had students that are stressed out about their lives, how they're going to get their degrees, what they're going to do with their life, and whether it was all really worth it. And so Jorge and I had lunch at a Subway, and we started bonding over our mutual love and respect for comics. Now, you got to realize this was pre-MCU. So two people having a conversation about comics of our age would be something that would be completely frowned upon by my colleagues at the time, at least. But we bonded over X-Men because we could talk about the metaphors in X-Men. It was just, it's very rich with meaning, or was to us. And so our conversation got around to the idea of the brain, what I was doing in my research. And so we posed a very simple question, which is, hey, Isaac Asimov says the most complex organization of matter in the universe is the human brain. What would it be like to try to express that in what is thought of as one of the simplest modes of storytelling in comics? And so we went from there. And from that, we created some comics for the Stanford D School to start off with, just as experiments to see if we could do it. And then we entered a contest that was sponsored by the National Science Foundation and won in the category of informational graphics for this comic on brain development. So from that point, we went on and we got a really interesting gig with Scientific American Mind, an off-print of Scientific American, to do comics every 2 months. And so for 7 years, we were pumping out comics on different topics in neuroscience. And so what is it about that concept of using comics for conveying neuroscience and to teach, in some respect, the public about the wonder that we feel when we consider the brain? It's because comics provide opportunities for you to stand inside a synapse and let neurotransmitters rain down on you. They provide a perspective and a way of storytelling where you can link back not only to the basic science, but also to some of the philosophical underpinnings that have led to the progression of science over time. So we've had comics about time, about enhancements to humans in the form of things like deep brain implants and prostheses. How much coffee is too much coffee? And there is an answer in that comic. And probably one of my favorites is this one where we take the brain and we sort of break it down into a basic set of numbers. And that was a really fun comic to work on. And then also weird things that people don't normally talk about too much, like the blood-brain barrier. It gave us an opportunity to take those concepts that are kind of, if you think about them in some respects, are a little boring, and try to inject some liveliness into those. And so from there, it was a natural step for us to say, well, these comics are great. I think they're great, but they're limited in that, if you look at the text in them, there's probably, 300 to 500 words, depending on the comic. And so more recently, we started thinking about how do we take this up a level? And so inspired a little bit by Watchmen, we decided that we would put prose into some of the ideas that we're working on, as well as just developing them as artistic works in the form of comic storytelling. So we started with a very basic premise in the first chapter of the book. And what I'm going to do is, it's impossible for us to cover the entire book. We actually, Jorge and I, read this book cover to cover for the audio version. So if you want a really strange experience, listen to the audio version. But it took 7 hours, I think, of total recordings to get the book out. So it's over 360 pages, and it's very well referenced. But it's not dense. That's the thing that was really important to us. The thing that was most important, I think, for us is, can we write a book about the brain that is really accessible to anyone? And probably one of my favorite reviews that we got was that there was a tagline that said, "Neuroscience for all of us." And I said, you got it. That's exactly what we were trying to do. So picking up this book, in my view, is picking up something that is easy to interact with. It's very accessible, and it does deal with these very fundamental questions that we have about ourselves, or at least stuff that we like to talk about around a water cooler, right? It's just stuff, what is consciousness? How do we love? What is hate? Those are the basic questions that we deal with in the book. And also some weird stuff, and sometimes not so pleasant stuff, like what happens when we die. If you want to know the answer to what happens to you when you die, buy the book. So that's all I can say. So one of the first questions that we dealt with, I'm getting ahead of myself. So this is where the experiment comes in. Things go wrong. You form a hypothesis. I clicked, and now I've formed a secondary hypothesis. We're going back and testing it again, and now we're back on track. So the first question is, where are you? Because that was one of the first questions that I, as a young boy, growing up in the piney woods of South Alabama, asked myself. And, for me, the answer was kind of easy, because I thought, it feels like I'm behind my eyes somewhere. Does everyone sort of feel like you're behind your eyes when you think about where you are? A lot of people do, I think, because we're very visual creatures. And as you grow up, then you get a more sophisticated idea of where you are. But if I asked you to point your finger, where do you think you are exactly? Some of you may have very different answers to that. Well, the reason is, where you are is a very complex question, even though it seems very simple on the face of it. So, one way that we found out about where we actually are is through observation. And the observation is of individuals that sometimes we, as scientists and as medical people, will call nature's experiments. Except this experiment was not very natural. It was a very unnatural experiment. And this is about a fellow named Phineas Gage. Many of you, some of you, I know this fellow down here knows who Phineas Gage is. He was a foreman that was working on the railroad in Cavendish, Vermont. Now, the work of putting together the railroads for this country was very arduous work. And what Phineas Gage did was, he was the foreman in charge of going and busting up boulders. And the way they did that was they drilled holes first into the boulders. They would place blasting powder into those boulders, and then they would use a tamping rod to drive the powder into the boulders. Then they would detonate it. And when they detonated it, it would split the rock open into smaller pieces, and they'd take the pieces away. And that's how they sort of blast their way through the mountains. Now, one day, this fellow made a mistake. And the mistake that he made was, he was standing in the wrong place, and there was a spark that ignited the gunpowder that was inside one of the holes in that boulder. So the boulder became the world's largest gun at the time. And it shot that 3-foot-long tapered tamping iron, under his left cheekbone, through his brain and behind his eye socket and out the top of his head. The miraculous thing is he survived that, but not completely intact. Because when we talked about Phineas before the accident, he was a stand-up guy. He was, after all, a foreman. He was someone who was very reliable, very mild-mannered. But after the accident, it changed him. And some folks say that he was no longer the person that he was because he would take to bouts of profanity, and he was not very reliable. In fact, he had trouble holding jobs after this accident happened to him. But as a result of his accident, we found out that the role of these frontal lobes is absolutely essential in how they interact and modify our behavior. So the first part of where you are, there's a big part of you that has to do with your frontal lobes and how your frontal lobes modify your behavior. Another important patient in the history of neuroscience is Henry Molaison, also known as patient HM, was known for patient HM for decades. Henry, at a very young age, had a bicycle accident. Sounds pretty benign. Just had a bike accident. But he developed what we know now is a form of post-traumatic epilepsy. And his seizures could not be controlled with the medications of the day. And it became so severe that as he became older, it was apparent that something needed to be done or he was going to have seizures and die. So a neurosurgeon, William Scoville, bored holes into his forehead, lifted up those frontal lobes, and then basically extracted or sucked out the hippocampus of his brain on both sides of his brain. Now, that left him with a devastating set of symptoms. The main problem that he had was that he could no longer form new autobiographical memories. He could remember everything up to the point of the surgery. But if you met him one day, you walked away and then came back the next day, it's very likely he would not remember anything about you at all. It would be as though you were meeting him once again for the first time. So a very famous scientist, Brenda Milner, a psychologist, decided to study Henry and found out that this memory deficit was not absolute, that there were actually different forms of memory that still existed within Henry's brain. It's just that the hippocampus was not essential for the execution of those memories. So what they found essentially from this strange experiment was that there were two types of memory. This sort of procedural memory that could be learned over time that was residual to his surgery, and then the deficit, which was the inability to form new memories. So where you are is also not just your memories. It's not just your ability to control your impulses by your frontal lobes. It's also your ability to communicate. And that communication takes many forms, but one very important mode of communication is speech. And so in the 1860s, Paul Broca observed a patient who had had a massive stroke, a patient who was called Tan. And he was called Tan because the only word that he knew was tan. And he would call his bacon, lettuce, and tomato sandwich Tan. He would call his wife Tan. That was the only sound, the only word that he could make. And on a post-mortem examination of his brain, after the patient unfortunately died, they could see the massive damage to a specific area that came to be known as Broca's area. Just shortly after that, and inspired in part by Broca's findings, Carl Wernicke had similar patients, stroke patients, who, while their ability to speak seemed unimpeded, they would speak gibberish. They would not be able to form coherent sentences, even though they could say complete words. And he discovered that most of the locus for that deficit occurred in an area that's roughly here, just above your ear, about an inch or so. And that's called Wernicke's area. And those two areas are connected, both the area for interpreting, understanding language, and the areas for generating language. If you get a deficit or have a stroke in one of those areas, and that's one of the reasons why folks that have strokes and tend to have them on the left side of the brain because of the anatomy of the vasculature. That's why those language deficits could be so profound. London banana dogs. So the other thing is, I guess I'll cap that section of the talk off by just saying that here's the point. The point is that you're not in any one place. You, the you that is you, is a function of all the areas of your brain working together in unison. And it's not just simply anatomical areas that if they're X'd out, you have a deficit. These areas are connected by literally trillions of connections. The last count that we had, the human brain had about 86 billion neurons. Each of those has on average about 10,000 connections. So you have hundreds of trillions of potential connections. And they're both long-range connections, connections from one side of the brain to the other, but also short-range connections that are locally processing information. And it is not only these little processing units, it's the activity that occurs in between them. It's the electrical discharges that they create, and it is the waves that they send through the brain that helps to unify and create this unified sense of you as you are, and the feeling that you have that you are uniquely you. So part of that, those feelings, and part of what we explored in the book was this relationship between love and hate. We have separate chapters for love and hate, but I started thinking about this for the purpose of this talk, and there's a lot of commonality between those areas. We think of love as this very positive emotion, and it is. And it is it is involving areas of the brain that drive from very basic motivations. And the areas that it is most concerned with is some of the dopamine-producing neurons of the brain's reward system. We find love rewarding. But that's not all that there is about it. When people talk about dopamine, they talk about it in these glowing terms like it is the chemical, right? It's responsible for everything. But it's really a misapprehension of what the dopamine system is about. The dopamine system is actually the brain's teacher. It is a system that is there to evaluate activity that you undertake behaviorally and determine whether the reward that you get back from that is greater than you would have expected. And that's what rings the bell for your dopamine system. So if you think about it in those terms, then the idea that love and hate might have some commonalities suddenly starts to make a little bit of sense. I don't know about you, but I know some people that seem to enjoy getting angry, seem to, gain some power over other people by being angry and mad and upset and unkind. And you know that person doesn't you can tell yourself, hey, no one rationally would be that way. So what is it about that? It's probably because somewhere there was a reward and there was a greater than expected return for that behavior. And so it begins to make sense that perhaps some of these common areas related to human motivation might be activated, even in the case of something that seems as disparate as love and hate. We come by hate honestly. It's part of our evolution. This comic is actually of a real event that happened in the 1970s. It was a war that was waged between chimpanzees in the Gombe Preserve. And it's part of a group of chimpanzees that were being observed by Jane Goodall. And what she observed was there was this group of chimpanzees that lived together, were related to each other, but got separated geographically, where some of the individuals moved off and founded their own group. And so suddenly the group that was part of the same family found themselves at odds with one another, to the point that it led to violence. Now, part of that was scarcity of certain resources. Part of it was the fact that there was a scarcity of females, and so that tended to increase their risk for violence and conflict. But it really boiled down to the fact that there were two groups. And we have copied that. We have found ways to define ourselves in groups, whether it's through politics, whether it's through religion, whether it's through universities. And part of the reason that we do that is there has to be some sort of evolutionary advantage to these kinds of relationships where you are protecting the resources, and those that act in certain ways protect those resources, and they are capable and able to transmit their genes to the next generation. And those that don't have those protected instincts do not. However, as human beings, we don't need to be driven by those things anymore. We can step back and realize that we live in a plentiful society, that the resources are not scarce, and we don't need to create artificial reasons to create in-groups and out-groups. So what do we learn from this sort of idea? We learn that just as the brain can do things in a positive way and can wire itself and has enormous capacity for plasticity, the brain can also wire itself in inappropriate ways, and in ways that are not conducive to a well-functioning society. And the speed at which information travels within our world is much different than the speed at which it travels in a world filled with chimpanzees. Now, the stakes are different, but the reality is that the underlying motivations can be very much the same. So can we do anything about that? Yes, if we start to consider that maybe some of these basic brain mechanisms are involved, then we can take extra steps to extend empathy. We can take extra steps to ensure that we have access to people that we would consider to be perhaps in an out-group. So that's why the idea of diversity is actually a very important idea, because it helps us to break down the walls that would create these barriers that lead to hatred and to othering of individuals. So, things suck. Things kind of do suck right now. And I don't know if you have that experience, but I don't know. It just feels like the last, couple of months, I don't know what happened, but it's like the last couple of months have been like
I think
years.
I know what happened.
Do you have a hypothesis? I don't know. But anyway, it's really important, I think, to sort of acknowledge, hey, things are kind of weird right now. How do we hold the center during all of this? How do we ensure that life doesn't sort of, take us by storm and create opportunities for us to fall into despair? So, some of these hateful people can actually be very hurtful, but there are ways that I think we can think about this, and honestly, not just neuroscience, but the history of psychology and philosophy can provide a little bit of guidance about how to deal with these kinds of situations. So back in the 1940s, Abraham Maslow proposed this pyramid, and it is kind of like a video game where, if you take care of your basic needs, then you can ascend to the next rung of that pyramid, or you can sort of level up. And his hypothesis, or really just kind of theoretical construct, was that you really need to fulfill your basic needs before you could start to climb this pyramid and start to have more happiness and more self-actualization. And so, there have been some arguments about whether this is strictly accurate. Scientifically, it's been both denied but also validated in some studies. But I think it's also just kind of a useful way of sort of framing, our own journey. That when you don't feel safe about meeting your basic needs, and it's really difficult to be truly happy. And so we explored some of those concepts in the book, and some of those concepts had to do with money and the role of money, and whether you could actually have enough money that would make you happy for forever. And it turns out that there is a relationship between happiness and money. But it starts to play out at a certain level. And after that level, you don't really become happier. And in the studies that we looked at in the book, it was around $100,000, but I'm sure it would be very different depending on where you ask those questions around the country.
You can skip it.
No, I want to see what happens.
Let me think.
Survive being in Harvard. Pay for Harvard. The next one should be pay more for Harvard. And the last one should be lose your house because you paid for Harvard. Yeah, that's the important part, right? All right, that's enough of that. All right, so Zeno of Citium, 2,300 years ago, founded a philosophical movement called Stoicism. So any of you know what Stoicism is other than just kind of vaguely the word? Well, Stoicism, for those of you that don't know, is really just kind of a way of viewing the world. Marcus Aurelius was like a famous proponent of it, and he wrote a wonderful treatise on it called Meditations, and I would highly recommend that you take a look at it. But essentially what it boils down to is this. It's the stuff that happens to you is in part what you bring to the table and the story that you tell yourself about what happened. So let's say you lost $100 since I'm talking to you. How would you feel if you lost $100? Let's say it's $1,000 for inflation. Oh, okay. But if you had $1,000 and you lost $1,000, there are ways that you would think about that that might not be so great, right? You might say, wow, I shouldn't have lost that money. I could have done a lot of that. I could have bought something for mom and dad with that. Or a video game or something. And you could have had, some negative self-talk about that where you said, hey, this is not something that I feel I'm lousy, I shouldn't have done that, it shouldn't have been something that I did, and I'm foolish and stupid for having done it. But the Stoics would say, you should think about it a different way. And that different way is simply, hey, I lost that money, it's important, and I shouldn't have done it, it's unfortunate, but I'll make more money, and I may not find this money again, but whoever did find it may make good use of it. And so you contextualize it in a way that helps you to move forward with your life and not fixate on it. And it sounds simple, but honestly, it's something that a lot of people have difficulty doing. And it is one of the keys to a lot of current and modern behavioral therapies, such as cognitive behavioral therapy and rational emotive behavioral therapies. Those therapies are based, or at least claim to be based in part, on this sort of outlook of Stoicism. So the other piece of this that we looked at in the book was also this relationship between money. And as I mentioned before, money can actually make you happier if it's meeting your basic needs, but not so much if you get over a certain amount of money. But money also comes with choices. And the choices that we make can also make us unhappy. And there are studies that we review in the book where people are presented with different choices. So how many of you have ordered something off of an online retailer lately of some kind? A lot of you have. Well, I looked for a toothbrush the other day, and I found out there are about 1,000 different types of toothbrush that I could order. And, part of that kind of made me, weirdly upset, because, there's something like fundamental about a toothbrush. Why do you need like 1,000 toothbrushes? I don't know. So that level of unhappiness or concern at the other end of it, when you don't have enough choices, also puts you in a state of mind of deprivation, that you aren't provided sufficient choices. And that can make you upset for a different reason. So there's sort of a Goldilocks effect, where if you don't have enough choices, but if you're given too many choices, you feel unhappy. But if you have just the right number of choices, that's the greatest level of satisfaction that you can have when choosing among alternatives. And it's not just the number of choices. There was a very poignant study that we looked at for the purposes of the book, where parents were given the choice to take charge of their terminally ill child's health care and make the decisions about that child's treatment or not, or the choices were placed in the hands of physicians. And what do you think the outcome of that study was? Now, we're taught, and honestly, current medical practice is we put a lot of information and choices in the hands of patients, but would it surprise you to know that the people who put their choices in the hands of trained professionals felt better about the outcomes? And the reason is they did not need to internalize the guilt for having made the wrong choices. So that is another way to sort of measure and meter. Not, in this case, there's no happy outcome. There is just less severe and less catastrophic personal outcomes. So are there ways that we can really be happier? There are a lot of ways that we can be unhappy, and our society has created enormous opportunities for bad stuff to spread and for us to try to compare ourselves with other people. Social media these days is attacking our kids with ideas that they're not pretty enough, that they're too fat, that they're not smart enough, they don't sing as well, their Instagram filters aren't as great, make them look as good. All of those things are potentially very hurtful for developing brains, and we need to be very careful about how we introduce those things to our children. Simplicity is another element of happiness that we discovered through looking through through our research. And it's the idea that if you look at monks, Tibetan monks, they're some of the happiest people, but they have probably less than any of us in terms of physical possessions. And it's the idea that they extend themselves in gratitude to the universe and invest in things that are greater than themselves. And that is an important idea that I think all of us can learn from, is that the sense of purpose, the sense of community investment can itself activate these powerful reward systems and lead us to better personal mental health and outcomes. So another concept within the book is what makes us human. And that's a very complex question, because it's not just having the biggest brains. This is a chart that just shows the relationship between brain weight and body weight. And humans do have a lot of brain matter for their body weight, but so do African elephants, Asian elephants, and dolphins. And they're not launching spacecraft. Thought of in terms of just, the success, an evolutionary success, what do you think the most successful creature is on this planet? It's probably something like bacteria in terms of just raw numbers of creatures, right? The biomass probably exceeds human beings. And there are even creatures with brains that have existed far longer than we have. For example, horseshoe crabs evolved somewhere around 450 million years ago. And you can still find them on the beaches. They're doing fine. So it's not the fact that, what we are is that much more special. It's that what we are is enough. It's good enough. We didn't kill ourselves yet. We were able to spread our genes and transmit our genes into new generations. But that's not what makes us human. It's not what makes us special, because lots of creatures can do that. One of the things that makes us human is our ability to create symbolic language. And that's important for a number of key reasons. Yes, there is a neurophysiology and a genetics associated with our ability to create language and to create symbols and to work with tools. But it's important because we can now pass notes in class, but not just do that. We can also transmit ideas through time, and we can accumulate knowledge in ways that other creatures find very difficult to do. There is something in the psychology literature called the end of history illusion, and it goes something like this, where you ask somebody if they're 18 years old, are you the best version of yourself you'll ever be? And the answer is almost invariably yes. If you ask the same person 30 years down the road, are you the best version of the person you'll ever be? And they'll still say yes. So part of what we postulate in the book is that there is an end of evolution illusion, that we think that we're the hottest thing on the planet. But the reality is evolution is still working around us, and we don't know what the final outcome is yet, and we don't know whether our unique brains are necessarily going to be the thing that allows us to continue to survive and to thrive. So this is one of the, I think we have maybe two more sections here. I want to talk a little bit about AI because everybody's freaked out about AI. And they should be. AI is an important concept. It is something that some of you may already be using. How many of you use AI or have played around at least with some of these chat bots? So the large language models are really interesting, but really what they are is they do predictions. They basically predict on the basis of the organization of a sentence what the next word in a sentence is going to be, and it takes that to the nth degree. And there are some of these models that do deep learning and create, what appear to be, almost thoughtful results. But so far, the number of parameters in some of these models is still not quite what we have and what we possess within our human brains. And one of the concepts that we talk about in the book is, and I think it's an important one, is it sufficient just to have a bunch of neurons? I think that misses the point that our human brains evolved over hundreds of millions of years. Starting back, when the first creatures were there, some of the same components that were in basic bacteria still exist, and we share some of that DNA. But not only did we evolve, we also develop. We go through a period of childhood. The different parts of our brain some of which I just illustrated, were, they learned how to grapple with the environment. Your visual system learns how to see. Your auditory system learns how to hear. And that is something that sets us apart from any of the machines. And that is the thing that while, these creations are wonderful, and they can help us discover new drugs, they can help us spot tumors in medical images, but you don't see Mr. Data walking around yet. And you probably, Mr. Data from Star Trek, for all you Trekkies out there, he's not here yet. And I think there's going to be some time before he can be here, because there's a lot that has to be learned about how human brains are structured before we can actually build competent, moral, ethical, artificial brains. So, when they get here, I guess we'll know it pretty soon. Hopefully they'll talk to us and they'll tell us, where we're going wrong, and they'll fix all of our problems. But, if they don't, then you'll know why, because they're based on us. Oh, okay. I was wondering where you were going with that. I was looking a little more than PG rated there for a second. So, and I'll leave you with this. The real final frontier, again, Star Trek reference, is the space that's between your ears. You're a wonderful creation of evolution and neural development. You, without even thinking about it, are capable of enormous numbers of calculations every moment of your waking life. You are learning even while you're sleeping and don't even realize it. And you are more than just the sum of your parts because of the wonderful lattice work of brain connections and the cascade of neural activity that is going from one part of your brain to the other. So what is next for the human brain is really up to you. And I think one of the things that I'd like to leave you with is this is not just the province of people like me, of neuroscientists. The thing that I would like to connect you with is the idea that all of you have a stake in what we learn about the brain. I dug ditches for a living to work my way through college during the summers. So whether you're a ditch digger or whether you're a podcaster or a cartoonist or a scientist or a homemaker, you have a vested interest in understanding more about this wonderful creation that we all share. And so I want to make one last point, and I want to thank you for this talk, because I'm just sitting up here saying words. He's drawing pictures, and some of them were funny. I mean, give him a hand. He did a good job.
Oh, all right. Thank you. I'll take some.
But the last thing is, we didn't do anything other than these little bits and parts. It's really you out there, you hearing the sound of my voice causing vibrations in your eardrum, that creating vibrations in the bones of your middle ear, that ringing your tympanic membrane, causing a distortion in the fluids in your cochlea, causing an encoding of that distortion into neural activity that's then projected into the inferior colliculus and then makes it to the medial geniculate and then up to the auditory cortex, where you figure out, hey, I understand that. And I'm able to conceptualize all of that and I didn't have to think about it. In the same way, you saw his visual picture, the pictures and cartoons. And those were wonderful as well, because you were able to conceptualize those and understand how those accentuated some of what I was saying, and it made you think of thoughts of your own. That's the other thing, and that's the beauty of comics, honestly, is that your interpretation of comics also depends upon what you bring to the table culturally, intellectually, and your own brain bringing your own experience into your understanding of the physics of the world and how the world works in order to understand it. So in a really real sense, I want to thank you for lending us your brain tonight so that we could communicate better with you. So I really appreciate that. The last thing, there's a lot we didn't talk about. Again, we read this book for 7 hours, and it's richly referenced. There's a lot of stuff in here. Consciousness is like we could have done the whole hour just on consciousness and models of consciousness, that unique feeling of being you. Memory, how do we store and encode memories? What is addiction? All of us, how many of you have someone in your life that's suffering? I won't ask you to raise your hand because you know who you are. If you have someone in your life who's suffering with addiction, I do. I have someone that I know very well that's suffering with it. So it's important to understand it. And finally, where do brains come from? So we talk about the evolution of the brain, where we think most of the components of the brain came from, and what that means to us in terms of our relative place in the world compared to other creatures. So thank you for your attention. Jorge, thank you for the annotations. I really enjoyed it. I didn't see all of them.